Hi gang, today we're going to work on reviewing rationalizing a denominator. So if you recall, there's a couple rules you have to follow in terms of radicals, what their final answer should look like. So a radical in the denominator is not considered simplified. It needs to be brought up to the numerator. It's a little more difficult when you have two terms in the denominator with a radical versus one. So if you have two terms in the denominator with a radical, you actually have to multiply by the conjugate, okay? So this is a little more difficult. So let me just remind you real quick. So if you just have a plain, let's say you just have a radical 3 in the denominator, just have one term, that's a lot easier to kick out, right? Because then you can just give it a twin. And then this would simplify to 5 radical 3, right? This would end up being radical 9, which simplifies out to be 3. So if you just have one radical in the denominator, you just, depending on what the index or root is, you just have to simplify it out. But if you have two terms in the denominator and at least one of them is a radical, that's more complicated to simplify. That's more complicated to rationalize. So how you have to rationalize that is you have to multiply by the conjugate. So let me see here, see if we can see this clearly. Okay, so the conjugate, I don't know if that's clear enough. Let me go back to this. The conjugate is when it looks identical except the sign of just the middle term is opposite. And what the conjugate does is it will kick the radical, it will simplify the radical out of the denominator. So let me just say that one more time. When you have two terms in the denominator and at least one of them is a radical, to rationalize the denominator, you multiply by what we call the conjugate. And the conjugate is where it's identical except the middle term is opposite. Make sure you multiply up down by the conjugate, right, to both the numerator and the denominator to keep the fraction balanced. Now, the conjugate's going to give you out, like if you had a minus b times a plus b, you're going to get a squared minus b squared out. There'll be no middle term. But I'll just write everything out in case you need to see it. But if you're really comfortable with this, you just have to multiply the first term times the first term and the last term times the last term, because what happens is the middle terms will cancel. As you can see here, if I wrote everything out, oops, hold on one second. As you can see here, if I wrote everything out, the middle terms are going to cancel. The same thing's going to happen here. But let me actually just write everything out in case that's something you want to see. So I'll first start by FOILing out the denominator. So remember, when you multiply, it's outsides times outsides, insides times inside. So non-rads times non-rads, rads times rads. So 3 times 3 is 9. And radical 3 times radical 3 is radical 9, because they're both under, so you can multiply. So 3 times 3 is radical 9, and of course that's going to simplify. If you want to do it now, if you want to go to the next line right away, this would come out as 3, and then this 3 would multiply times the 9, and that would make a 27. Okay, if you want to just simplify that first piece all the way. Right, that's that one times that one. Now this one times this one. So you're going to multiply the non-radical part by this this integer. Okay, so 3 times 4 is 12, but then you still have this radical 3. So remember, you combine the non-radical parts together and the radical parts together. All right, now this times this is going to be negative 12, right? Because the outsides go together. Radical 3, and you can see what I was saying about the middle terms cancel. I'm showing it to you. Okay, so as we said, this and this is going to, these like terms will go away. And as you can see, what was left was the first times the first, which is this, and the last times the last, which is this. So let's go all the way with this. So now you can do the 27 minus the 16. I'm just going to keep with the denominator for a minute. You can do this however you guys want. I'm just going to stick with the denominator. Okay, that's 11. Now, if you notice, I waited to distribute this in because if you're going to reduce the fraction, you have to reduce it over multiplication. So let's say, for instance, and this isn't true, but let's say in a different example, the denominator came out to like 20, and there was a 4 up here. I'm just making stuff up right now. You would then want to reduce the 4 and the 20, okay? So you sort of wait to see if there's an integer in the numerator, you sort of wait to see if that will reduce if there's an integer in the denominator. But there wasn't, so I'll go ahead and distribute this in to both terms now. So this will be 15 radical 3 plus 20 over 11. Okay, gang, so I didn't like rewrite everything 101 times. I certainly could have written out the numerator a few times if you want to see it. So what I'm stressing here is please simplify the the denominator first, and then figure out how you want to handle the numerator. I think that's a really good procedure to follow. Just in case your fraction reduces, remember it's going to reduce over multiplication. So if you distribute out the multiplication, you won't be able to reduce the fraction if there's an integer in the denominator. This one just didn't happen to reduce because 5 over 11 doesn't reduce. Okay, gang, this video is actually already almost at 7 minutes, so I will do more of these, but let me just pick them up in the next video. So let me end this one here. I hope you enjoyed it. Bye-bye.